So for assignment 2, we're going to be adding a step sequencer to the subtractive synthesizer that we made for assignment 1. This is the same synthesizer I created for the video for assignment 1. I added a couple of different things. I added a preset object, I added a transpose control for our pitch, and the keyboard controller that we can use to play our synthesizer, and then made a couple of presets. So if I play this, I'll play through the different presets. So that's my basic subtractive synthesizer. What I'm going to do is I'm going to add a sequencer to it, and I'm going to use this diagram as the guide for my sequencer. So here we can see this section is essentially exactly the same as our subtractive sequencer diagram that we used to make our subtractive synth. The only thing that's really added is this section up here, and it's actually fairly straightforward. So the most important part of this is our actual step sequencer itself, and Max provides several objects that can be used for creating step sequencers. We'll take a look at live.grid, multi-slider, and itable, and see how we can use the information properties panel for each of these objects to configure it to be able to be usable for our sequencer. So I'm going to start off though up here and just sort of make all of these objects, hook them all up, and then go through and take a look at these objects afterwards. So the first thing I'm going to do is I'm going to create a metro object. A metro object is essentially like a metronome. I'm going to turn my volume down just so it won't keep making noise. So this is going to just send out a bang at a regular interval. I'm going to set the interval of it right here, but I can also look at my inlet. I can send an integer here to set the interval to be a different interval than 200, and I can connect a toggle box here to turn the metronome on or off. So in my diagram I can see to turn my metronome on or off I need to send it to 0 or 1. The max object to do that is a toggle box. I can make that just by typing T. So it's one of the special hotkeys. You can just make a toggle box just using one letter press, one keyboard press. So now I've got a metronome. It's set for 200 milliseconds between pulses. If I turn it on, that's what I'm going to get. I can change my speed of my metronome here. So now it's every half second or every second or even faster. You don't really ever want to go too fast with this. If you go down to 0, you'll kind of hang your computer. You can go down to 5 milliseconds. It's pretty good. Even 4 or 3 milliseconds is pretty good. If I go all the way down to 0, then it may just hang my computer. All right. So that is my metronome. I'm going to use my metronome and use a counter. So all the counter is going to do is just going to count bangs. So I'm going to have my counter here. So every time a counter receives a bang, it's just going to count up. So let's take a look at the output of the counter. Turn my metronome on. Whoops, I've got a really fast metronome. Look at those. That's how many bangs the metronome's been putting out, right? So let's get back to a more reasonable speed. So I want my counter actually not to count just continuously up. I want it to count it between 0 and 7. And 0 and 7 are going to be the 8 values I'll use to drive my 8-step sequencer. So now, if I turn my metronome on, I can see, make it a little slower, that my counter is counting from 0 to 7. And that's what I think I can actually just do this. Just type 7, type your maximum value right there. All right, so going from 0 to 7 with my counter. And the next thing is to create my actual step sequencer. So let's take a look at 3 different objects. I'm actually going to start down with itable. So itable, and all of these objects, by the way, are going to be user interface objects. So I'm going to create a new max object, n, type in itable. Now when I push return, this is going to disappear, and we're going to see the interface for the itable, which is this right here. If I lock my patch, go back here, I can interact with my itable and draw patterns in it. So all this is doing is creating a sequence of data. This, by default, is 127 steps, 127 possible values. So you can see the x, y coordinates going up between 0, 0, all the way down here, and 127, 127 all the way up here. So that's not the range we want. The range we want is going to be between, we want basically 8 steps and 8 possible values. So I'm going to go to my iTable box, I'm going to go to the inspector right here, and this is going to open up a panel where I can set the properties for this iTable. So I'm going to scroll down, I'm going to go to the table range and table size and set them both to 8. So now I'm going to lock my patch. I can set my table in sort of a more reasonable number of steps. So that's an iTable. If I connect the output of the counter object to it, and I take a look at the output of the table object, so now what's going to happen is the incoming value is going to be the index of this table, and the output is going to be the value at that index. So this is index 0, 1, 2, 3, 4. So index 0 should give me a value of 6. Index 1 should give me a value of 3. Let's see what that happens. So I'll stop at 1 is a value of 3. If I stop at 0, value of 6, right? So you can see it's just going to step through these values. All right, so how are we going to use those values and map them to our pitch of our subtractive synthesizer? So here we already have a receive object. So in Max, there are a couple of ways to make your life a little bit easier as far as sending data around. And one is that there are send and receive objects, which are, you can sort by short, you can just say S and R. So a send object, if I type S, I also type out send, it's the same thing. I'm going to type out S for now, S key. So I named this send object key. This is a receive object also named key. So any data that comes into this send object will get received by this receive object and will get sent out. So let's try this. I'm going to make a number box. I'm going to send the number 60 to my key object. Whoops, and it doesn't work because there's something special going on here. So our keyboard here sends out a message. Actually, let's take a look at the output of a receive object. So I'm going to make a new object, receive key, and I'm going to use a message box to monitor what's coming out of that object. Remember, the nice thing about a message box, and I'm using the right inlet of this message box to do this. The nice thing about a message box is it'll show you whatever comes in. It doesn't matter if it's a list or a word or a number or anything, the message box will display it and tell you what it is. So if I press the keyboard now, I'm going to play my keyboard like I would up here. I get a note followed by a note off. So I push B, I get pitch 67, I take my finger off, and I get a note off message. So you can see that what's coming out of this key object is not as simple as just a number representing the pitch. Instead, we get pitch 65, so we can differentiate between a pitch message and a note off message. All right, so we're getting a pitch message here. So what that means is before we send this number to our key box, we need to make it a pitch message. I'm going to use the message box again in a slightly different way. So now I'm going to connect, instead of to my right inlet of my message box, I'm connecting to the left inlet. Now what happens when you send something to the left inlet of a message box is it just triggers the output of that message box. So if I didn't have that 0, 1 there at all, I'll make another message box to monitor the outlet of this one. And I just click this box, I'm just going to get the word pitch, right? So just keep sending that word every time that box gets triggered. If I send in a number, again, all I get out of this is what's contained within it. Anything in the left inlet just triggers the value of that message box to get sent out. The only exception is if we have a $sign argument. A $sign argument is going to replace this value with the element that's coming into the left inlet. So this is going to say the first thing, whatever it is, could be number, could be a word, could be anything. The first thing that comes into the left inlets can replace this $1. So if I change my numbers now, I see it says pitch 122 because that 122 replaced that $1. Now if I wanted to, I could just send a random text message into this. Now it's going to replace the $1 by this value, right? So this $1 can be anything. It can be a float, an integer, a message, a string, or a word. Anything like that doesn't really matter. But for now, we know that we need this actually to be our number. So I'm going to take to my outlet of our sequencer. Actually, I'm not going to do that yet. I'm just going to take and make a number box, send it to my pitch inlet, send that to my send object, and I'm going to send in a message 60. So, turn my volume up a little so we can hear it. Here's my 60. So we should make a pitch. And we can just type in whatever numbers we want to play a song. All right. So we know that that's how we can get a MIDI note from here through the send object to get received over here, get routed to the pitch a pitch message gets routed to the first outlet, and this is our pitch that we send. So this number will be exactly the same as this number, which we can see is true. So now the outlet of this box, remember, is going from 0 minimum possible to 7 maximum. So how are we going to change this value to something that's going to make an appropriate MIDI note right here? And there's lots of different strategies to this. It's basically just math of different sorts. So the first thing we could do is we could just add some kind of default offset to it. So let's say we just add 48 to it. All right, well, that's sort of making notes, right? That's working. We could add an integer box here, change what our offset is. So instead of 48, we can make it be 32 or 60. So that's one way of doing it. Now notice though, what we get out of this is just sequential notes on the piano. So that every black and white key on the piano, and it sounds, you know, let's do this actually. Let's just listen to each note sequentially if we do that. So it's a chromatic scale basically. So it's not really a musical scale the way you might be used to, which is no problem because you can always just program the a regular scale here. So this will be like a minor scale. But I'm avoiding all of the black keys basically on a piano keyboard. So that's fine, we can do that if you want to, and that's an easy solution. Another option would be to, instead of just adding a number, we could scale the incoming values. So the incoming values are going to be 0 and 7. We could scale those, say, to 48 to 60. And let's see what that sounds like. So I'm just going to disconnect this one. And now we're just using our scale object. And again, let's just make a linear progression here. So it's not necessarily chromatic anymore, but it's a little bit unpredictable. The first note is a C. The next note is a C sharp. The next note is a D sharp. The next note is an F. The next note is a G, or I'm sorry, that's a F sharp. And then a G sharp, and then a B flat or an A sharp, and then a C. So this actually does make a kind of a scale. Essentially a C sharp scale. Here's our roots. But then we don't actually get up to the high C sharps. We get left hanging on our major seventh, which can be fun, but also stressful for some people. So, but we really, all we did here is we just kind of spaced those notes out. We didn't actually do any explicit mappings. We just kind of luckily ended up with a C sharp scale based on the way that the scaling algorithm worked. So there's another way to do this, which is a little bit trickier, and I'll show it to you, and this is something that you can use. So I'm going to make another itable. So I'm going to type in itable. Okay. So remember, by default, our itable has 127 values. So I'm going to change it. So I've got 0 to 7, so I've got 8 possible values here, so I need 8 steps here. And I'm going to map these 8 possible incoming values to 12 possible, or 13 actually possible outgoing values. So I've got 12 steps, 8 steps to 13 possible output values. All right, so here I go from 0 to 7 and from 0 to 12 here because I've got 13 possible outputs. All right, so I'm going to send this message number 7 here and this here. Now what I can do is I can map, I want the value of 0 here to be 0 here. I want the next note, 1, to actually go up 2 steps here. I'm going to recreate a major scale, right? Whole, half, whole, half. So here's my major second. My third note in this scale is going to be a major third. My fourth note is going to be a perfect fourth. My fifth note is going to be a perfect fifth. My sixth note will be a major sixth. My seventh note will be a major seventh. And my eighth note will be an octave. And so now if I turn on my metronome, I'm going to just go up a C major scale right here. And if I go ahead and add an offset here and send this over to my pitch, I'm going up a C major scale. So this is actually a way to convert sort of this linear numeric sequence of 0 to 7 to something that's spaced correctly for like a musical scale. You can make it a minor scale very easily. You can make modes you want to, a Dorian mode. Or you can make any kind of more exotic scale if you wanted to. Now you could also, there's no reason why you can't just make this be nonlinear as well. But that gets pretty complicated because if this is nonlinear and this is nonlinear, this just becomes kind of random. Which can be fun. But really this technique is more useful for creating a predefined scale, right? So like our major scale. All right. So that right there alone will get you to essentially get your sequencer finished. So once you've done that, you can save some presets. So let's go ahead and save this preset. And then let's maybe make a preset which is not so literal. If I wanted to change scales here, I could. I could also change tempo if I wanted to. Or slow it down. So lots of ways of messing around with these, and everything you do, you can save it inside the preset and it will save it. So that's using an iTable object. Oops. There are a couple of other ways of doing this, which kind of offer different kind of trade-offs, benefits, and uses other than an iTable. So one is to use something called, I'm going to go ahead and save my scale generator down here, but I'm going to delete the iTable. And instead, I'm going to replace it with a multi-slider. A multi-slider, it can be very similar to an iTable, but it's sort of by default a continuous value going up and down. And by default, when you make a multi-slider, it only has one big giant slider. So what I'm going to do is go in here, go to the inspector panel for our multi-slider, which is already pulled up, scroll down, and I'm going to say, let's make 8 sliders. And so now, this is 8 different sliders that I can use to output values. And if I were to connect a message box to the outlet here, I'll see the value of all 8 sliders. So taking a look at this, we can see that the range here is not an integer anymore. It's actually a float going from -1 to 1. If we look at the properties box here, it'll tell us our range of our multi-slider right now is from -1 to 1. We don't want that. We want our range to be from 0 to 7. And we also want to just send out integers. So now we can use our multi-slider just to send out values from 0 to 7 of integers, very similar to our iTable box right there. I'm also going to go in here, I'm going to increase the thickness of our line, make it a little bit easier to see them. And so now you'd think, okay, well now I can just send in a number and it should change the values of this multi-slider. But let's see what happens if I try doing that. So by default, what multi-slider will do is take an incoming value and just set all of the sliders to that value. So I send it a value and all the sliders get set to 0 through 7. So that's actually not what we need to do. Instead, we can take a look at this guy. I'm going to look at the reference guide right here. And the reference guide is going to tell me all of the messages I can send to this object to interact with it. So it will tell me, for example, if I send it a number like an int, it's going to set all of the slider values to that int and output a list. And that's exactly what happens. If I send it an int, it sets all those values and I get a list of all the values output. So that's not really very useful at all. So instead, let's go down and see if we can find something where we can get the output of just one of the sliders at a time. And that message is fetch. So down here it says the word fetch followed by a number sends the value of the numbered slider out of the right outlet. So instead of getting the value out of this outlet, which just sends all of the values, this outlet sends the value of only one slider. So in order to do this, I'm going to make a message box. I'm going to send a fetch message, and I'm going to follow that with the number coming out of our counter. So now the output of my fetch box, is going to be fetch followed by the counter number, right? There we go. We can see all of those, 0 through 7. And now nothing's coming out of this outlet because a fetch message doesn't do anything coming out of this outlet. Instead, it sends something coming out of this outlet. And the value is going to be whatever their slider is set to for that step. So that's actually kind of the same functionality as what's going on down here. I can send the output of this, let's make this an inbox just so we can monitor it, to the inlet of my iTable. Alright, so I can make what is a very reasonable something's not going right. So what's going on here is it seems like I'm just getting the value of 0 every time I send a 0 or a 1. So what does this mean? Maybe a value of 1 returns a 0, value of 2 returns a 2, value of 3 returns a 4. Maybe this is actually 1 indexed. Maybe it starts counting on 1. And then we're only on slider 7 now. Slider 8 should be right here. And then slider 1 would go back to the beginning. Okay, well if that's the case, then our counter is not going to the right range. Remember, our counter is going from 0 to 7. This is expecting 1 to 8. So let's go ahead and fix this. All I'm going to do is add a +1. So now our output of our +1 object will be going from 1 to 8. And that's operating more like I would expect it to. And looking at the sort of music here, I can see it's following the trajectory of that sequence. Alright, so that's using a multi-slider object instead of an iTable object. The multi-slider object is really useful in lots of ways. There's lots of different modes you can set it to. You can use it to send out floating point values or in a different sort of range of values than a table could send. Also, you have a lot of other functions or messages that you can send it to do different kinds of operations on the data. One thing I really like about the multi-slider is you can set it to send slider style as a line scroll. Now as a line scroll, I'm going to set a range of sliders to 1 and range to 0 to 1. This has nothing to do with the sequencer, by the way. This is totally, entirely unrelated functionality. What I'm going to do here is I'm going to monitor the output of this float box using my multi-slider. Whoops, I need to make this be sending out a floating point numbers. Alright, so it's set to floating point. The range is going to be from 0 to 1. There's only one slider now. And if I move this box, I can see the change of this box over time. So it's kind of a nice way of graphing control data. So if you're using any kind of a sensor input or anything like that and you want to be able to see what it's doing over time, you can use a multi-slider to do that when the multi-slider is in line scroll mode right down here. So line scroll is a fun object for lots of different reasons. Let's take a look at one more object which can be used to make sequences, and this is the live.grid object. So live.grid is one of the objects that MaxMSP made, or Cycling 74 made, to kind of bridge the gap between Max MSP and Ableton Live, which is a DAW, sort of another DAW software that a lot of people use. So the Ableton actually bought Cycling 74, and so they've sort of been slowly integrating in different ways. And one of the ways they do it is by having these live dot objects. So live.grid is essentially a step sequencer, kind of pre-configured in a couple of different ways. So just by itself, it looks like this. It looks a little bit like what you might imagine a step sequencer would look like. It also has these things down here, which we can use to, this is kind of confusing, reverse or stop the step. The functionality of these is actually kind of specific to some other live objects. And so for our purposes right now are not that useful, though I can imagine there could be ways these could be really useful. But for now, we're going to say we don't really like these. And obviously our range here is different. We were using a sort of an 8x8 grid, and this is much bigger than that. So I'm going to go in here and I'm going to configure it to get back to what we were looking for. First thing I'm going to do is I'm going to turn off this directions panel and just get rid of it. So that's just done right there. Go down here, I'm going to set again my values to 8 and 8. And now I've got a nice little 8x8 grid I can use as a step sequencer. Now something else I could do is I could change the locations of these indicator columns. So column marker, I could just say 8 and get rid of it. And row marker, same thing. So we just have 1 and 1. We could have 0 row markers and our column marker every 4 beats. However you want to do that, you can configure it. Now one thing about the live.grid object is it is also one indexed. So if I send it to 0 to 7, step 0 doesn't actually mean anything. The first step is step 1 in the live.grid object. So I'm going to keep my 1 indexing plus 1 right here. And I'm going to monitor the output right here. Now let's see what happens if I turn my metronome on. Okay, so that's kind of doing what we'd expect it to do, right? Should just be going up from 0 to 7. Interesting, the output of this is also 1 indexed. Now this is a bit of a problem because our I table down here is 0 indexed. So when I send it a value of 1 as the lowest one, this is the lowest possible output value. So when I take this and I use my I table scale converter, I'm actually going to have to I'm going to have to make this be 0 indexed rather than 1 indexed. And now this will convert it to the right range, and that should just go up a major scale. So I set to minor scale right now.